Hello and welcome. My name is Matthew, and in this lesson, we are going to discuss mole concepts. Mole concepts. So I'm going to give you the meaning of mole, and then I will show you how to calculate mole in chemistry and how to apply this mole in solving chemical problems. If you want to get the temperature of a substance, we use Kelvin or degree centigrade. If we want to measure distance, we use the unit meter. If we want to measure mass, we use the unit kilogram or gram. But in chemistry, if we want to measure the amount of substance, we use the unit mole. So mole is the basic unit for measuring the amount of substance in chemistry. And what is the definition of this mole? A mole is defined as the amount of substance that contains as much elementary particles as there are atoms in carbon-12 isotope. Carbon-12 isotope. Carbon exists or has different isotopes or different forms. We have the particular form we call carbon-12. The amount of substance in this carbon-12 is called a mole. So if we want to get the mole of any substance, we compare the amount of particles in that substance to the amount of particles in carbon-12 isotope. When we compare it, then from there we can now get the number of mole that the substance contains. Now this carbon-12 isotope, it has been found that the number of particles in it is equal to 6.022 times by 10 raised to power 23. The number of particles in this carbon-12 is equal to 6.022 times by 10 raised to power 23. This is the number of particles, the number of atoms that you can see inside this carbon-12 isotope. Therefore, this number is used when we want to calculate the number of particles in any substance, because we are comparing the number of particles in that substance to the number of particles in carbon-12 isotope. This number is called Avogadro's number because it was a scientist called Avogadro that first determined this number, that first found out that the number of particles in carbon-12 is equal to this number. So this number is called Avogadro's number. Now, in chemistry, we can use this mole to determine the number of particles that any substance contains. Therefore, we can convert mole to number of particles. We can convert number of particles to moles. We can convert moles to mass, and we can convert mass to moles. Now, let me show you how to do all these calculations. If you have a mole and you want to calculate the number of particles there, if you have a mole and you want to calculate the number of particles there, you say that the number of particles is equal to number of particles is equal to that mole that you have times the Avogadro's number. Mole times Avogadro's number. Let me use the initials AN to represent it. Avogadro's number. Avogadro. Avogadro's number. So if you are given the number of particles, or if you are given the mole of a substance and you are asked to find the number of particles that number of mole contains, you are going to use this formula that number of particles is equal to the mole that is given to you times the Avogadro's number. That is the first formula. Now, the second formula is that in case you are given the number of particles and you are asked to find the mole, then you use this formula that mole, the mole of the substance is equal to the number of particles divided by the Avogadro's number. This is the second formula. Then the third formula, if you are given the mole and you are asked to find the mass of the substance, then you use that mole or the mass of substance. You are given the mole and you want to use the mole to find the mass of the substance. Then the mass of the substance M is equal to that mole that is given to you times by molar mass. And if you are given the mass and you are asked to find the mole, then you are going to use this formula. The formula is that mole is equal to mass over molar mass. Mass over molar mass. Now, let me solve some examples to make this thing clearer. In our example 1, we have that calculate the number of particles in 2.5 moles of carbon dioxide. Calculate the number of particles in 2.5 moles of carbon dioxide. So we are given the number of moles here. We have 2.5 moles of carbon dioxide. CO2. We are asked to calculate the number of particles in this CO2. Now, in bracket, we are given that the Avogadro's number is 6.022 times by 10 raised to the power 23. In case you are not given this, you should be able to remember this number all the time. That Avogadro's number is equal to 6.022 times by 10 raised to the power 23. Now, what are we going to do? Here we are asked to find the number of particles and we are given the number of moles. So we use the formula that relates to it, which I gave you, that to find the number of particles is equal to, the formula for that one is number of particles is equal to the mole that is given to you multiplied by Avogadro's number. Now, what is the mole that is given to us? We are given 2.5 mole. Then the Avogadro's number is 6.022 times by 10 raised to the power 23. Now, this will give us, when you multiply these things, you are going to have what I'm going to have is that my number of particles here, the answer is going to be 1.022 0.055 times by 10 raised to power 24. Times by 10 raised to power 24. So this is the answer. So when you are given the number of mole, you can get the number of particles using this formula. That number of particles is equal to the number of mole given to you times by the Avogadro's number. Now let's look at another example. In this second example, we have that calculate the number of moles in 3.01 times by 10 raised to power 24 particles of sodium chloride. Now, here, instead of giving us mole, we are given the number of particles, and then we are asked to calculate the mole. So we use the formula that relates to it, the right formula for it. I said that when you are given the number of particles, then if you want to calculate the mole is going to be the number of particles that is given to you, number of particles, all over Avogadro's number, AN. So we are given the number of particles as 3, they say calculate the number of particles in 3.01 times by 10 raised to power 24 particles. So the number of particles is 3.01 times by 10 raised to power 24. So we substitute it for this. So here we have number of particles. We put 3.01 times by 10 raised to power 24. Now here we have Avogadro's number. We know it as 6.022 times by 10 raised to power 23. 6.022 times by 10 raised to power 23. Now when we divide this, whatever it gives us is the number of particles, and this will give us 5. So the answer is 5 moles. When we divide this, we get 5. So we get 5 moles as the answer. Now let's quickly look at how we can calculate mass when mole is given to us. Now let's calculate this. Calculate the mass of 3.5 moles of sodium chloride. Calculate the mass of 3.5 moles of sodium chloride. We are given sodium chloride and the mass of it is 3.5 moles. I mean the moles is 3.5. This is the moles of sodium chloride given to us, and then we are asked to calculate the mass of it. Now remember, I said that when mole is given to you and you are asked to calculate the mass, then the formula is that mass is equal to mole times molar mass. So it now means that we are going to calculate the molar mass of sodium chloride. How can we calculate the molar mass of sodium chloride? Here we are giving the molar mass of sodium chloride as 54.44 gram per mole. We are giving it. But in case you are not giving it, you say that the molar mass of it is equal to the number of masses of all the atoms that makes it up. So we have sodium chloride is NaCl. So you find the mass of sodium plus the mass of chlorine there. So when you add two of them, that will give you the molar mass of the sodium chloride. But here we are giving the molar mass. So there is no need of us calculating. In the equation we are giving the molar mass of sodium chloride as 58. We are giving in bracket that the molar mass of it is 58.44 gram per mole. So we now put it in the formula. We now say that the mass is now equal to, the mole is 3.5. We are giving the mole at 3.5. Then we multiply it by the molar mass, which is 58.44. Now, whatever this gives us is the answer. This will give us 3.5 times 58.44. That will give us 204.54. That will give us 204.54. So this is the mass, this gram, this is the mass of the sodium chloride. So we calculated it using the mole that is given to us. Now the next thing we can do, let's see if you can calculate the number of mole from mass. Now calculate the number of moles in 250 grams of calcium carbonate. We have calcium carbonate, CaCO3, and they say that the mass of it is 250 grams, and we are given the molar mass of it. They say the molar mass of it is 100.09 grams per mole. Molar mass of it is equal to, of the calcium carbonate, is equal to 100.09. So we are given these two values and we are asked to calculate the number of moles. Now I gave you another formula that number of moles can be calculated when we have the mass, and the formula to use is that number of moles is equal to mass over molar mass Now we have our mass there as 250. So we replace this mass here by 250. Then the molar mass, they say that the molar mass is 100.09. So we replace this with 100.09. So when we divide this, whatever it gives us is the number of mole. And the number of mole here, when we divide it, it will give us, this will give us 2.50 mole. So this is the answer. Okay, so this is how to calculate mole and how to convert mole to different terms. You can convert it, you can use it to get the number of particles, you can use it to get the mass of a substance. Alright, so in this topic, briefly, we discussed the definition or the meaning of mole, and then we also I showed you different ways that you can convert or you can solve calculations involving moles. Thank you.